Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to take a look at the product rule, another tool used for differentiation with derivatives. So let's go ahead and get started. So we need to review what we kind of talked about in the past so that we can further appreciate what we're going to be discussing right now. So we've talked about the constant rule. The constant rule essentially means that the derivative of a constant is going to be 0. And so if you have f of x equals 5, that means the derivative of f of x is going to be essentially 0, nothing. So this helps you to deal with constant numbers, which is important when you're dealing with derivatives. We've also talked about the power rule, which essentially means that when you have a function, so f of x equals, x to the third, it's very, very simple. You bring the exponent down to the front as a constant, or a coefficient, if you will, and you subtract 1 from the actual exponent as well. And so when you want to find the derivative of f of x, it's going to equal 3x squared. That's essentially what's going to happen there. And so this allows you now to deal with constants and also now to deal with stuff that is raised to a particular power. But what if you want to deal with two numbers that have a power as well? This is where you learn about the sum rules and the difference rule. And so essentially how that works is, you have f of x again, and let's just say you have x to the third plus x to the fourth. You just deal with each of these individually and you add them together. So the final answer is going to be the sum of the individual derivatives, if you will. So I applied the power rule this time, and of course I will get 3x squared plus 4x to the third. And of course, if there was a minus sign right here, I would just put a minus sign here down below. So the sum rule and the difference rule are the same, except whether you have a plus or a minus sign, essentially. And so this is how we can deal with this. So now we know how to deal with constants, we know how to deal with exponents, and we now know how to deal with more than one exponent in a particular binomial term, if you will. And so, of course, if I want to make this more complicated, and so I say plus 5, well, that's no big deal. I already know that that's going to be 0, so I would just put plus 0 down here, which pretty much ends that. Now, the next thing that we learned was the constant multiple rule. And so to do that one, it essentially means as follows. Let's say now I have f of x again, my favorite term, my favorite function, and I have 2x to the fourth power. What I do is I follow the rules from the power rule. In other words, I bring this 4 down here like always, and I just multiply it by the constant right here. And of course, I subtract 1 from it up at in the exponent. So I end up with 8x to the third power. So now I know how to deal with constants. I know how to deal with exponents. I know how to deal with multiple exponents and if even multiple constants if necessary. And now I can deal with variables that have exponents and also have a constant multiple in front of it. So all these tools are being brought together. And that brings us to something that's even more complicated, and that is the power rule, the product rule. And so the product rule is as follows. Let's say you have the following. I'll explain this from an abstract level first. So I have j of x equals f of x times g of x. So now you can clearly see that I have a multiplication of these two functions. And of course, we know the results of multiplication is a product. And so the steps for dealing with this are as follows. The derivative j prime x, if you will, if that's what we want to call it, is going to equal this. You take this first function f and you find the derivative, so f prime x times g of x. Like so, then you add it to the derivative of the second one, so this is going to be g prime x, and you multiply by the original function f of x here. This is how it works. Now, we've talked about this on a theoretical level, and so why don't we take a look at how this is actually going to play out. So we have the following function as shown below. We're going to do j of x, let me just do this on a new screen so I have more space. So our j of x is going to be, oh, I don't want the dot there. J of x is going to equal x squared plus 2, put that in parentheses, multiplied by 3x to the 3 minus 5x. So that's what we got. So we're going to label these just to make it a little bit easier for our minds. So this is going to be my f of x right here, and this is going to be my g of x right here. And so what I need to do now is that I need to find what is the derivative of x squared plus 2. And so if I go through the process of doing this, I take my product rule, my power rule, excuse me, and so I get 2x, and then I take my constant rule, it's going to be plus 0, so I don't need that. And I'm going to multiply that by g of x, which I do nothing to it right now. It's just 3x to the 3 minus 5x, like so. Now for the second one, I need to find the derivative of 3x to the 3 minus 5x for my first one. So 3x to the 3, so I bring the 3 down, that's going to be 9x squared. So first I use the power rule and also the constant multiple rule, so 3 times 3 is 9. And then I use the exponent rule, because the power rule, excuse me, as well. So that's going to be my 2 here. And then minus 5, like so. So that's the derivative of g of x. And then I just take good old-fashioned f of x. That's going to be x squared plus 2. So no changes there. Now, this is something we've all done many, many times before. We just, combine like terms or distribute the various terms as we should, and we get our ultimate answer here. So let's see here. If I do 2x times 3x to the 3, I should get 6x to the 4th power here, 6x to the 4th power, and then 2x times minus 5x should be minus 10x squared, and then we're going to plus that here. So 9x squared times x squared should be 9x to the 4th power, 9x to the 4th, and then 9x squared times 2 here should be 9x squared times 2 should be 18x squared, plus 18x squared. So we did these two terms. So minus 5x squared, multiply this, and then minus 10. And so now it's just a matter of combining like terms. So we're going to wrap this up here. So we got a 6x4 and a 9x4. We're going to add those together. That'll give me 15x to the 4th power. So let's see here, 8x squared minus 5x squared. If I cross this off, I will get 13x squared. And then I'm going to take minus 10x plus that. So I should get plus 3x squared. And then I have my minus 10 left over. And so this is our derivative for the function j of x. So the derivative of j prime x is the answer right here at the bottom, which is 15x to the 4th plus 3x squared minus 10. And that is our answer. So you can see that there's a lot more steps involved in how to do this. But the rule is to know when to apply a certain tool at the right moment. So whether it's adding, dividing, multiplying, subtracting, whatever, you have to know when to do it, and understanding these concepts will allow you to find the derivative for much more complex functions in the future. So let me go back and review what we talked about, and then we will conclude this video. So in this particular video, we talked primarily about how to use the product rule to find the derivative of a particular function. And so essentially what you need to do is that you're going to have to find two separate derivatives for the first term and also for the second term, as you can see right here. And what you do is you take the derivative of the first term multiplied by just derivative of the first function multiplied by just the function itself, no changes to the second function, and then you add that to the derivative of the second function multiplied by the first function with no changes to it. And then after that, you have to simplify by distributing or whatever it is you need to do, cancel out and combine like terms, and you will have an answer. And so right here was an example that we worked on together where we took j of x, which was x squared plus 2, that quantity multiplied by the quantity of 3x to the third power minus 5x, and by using the product rule, we were able to find the final answer at the bottom. So I want to thank you for watching. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.